Hi dear students, welcome to Math Solutions by Pani. Here we are in that exercise 2C. Find the value of cos inverse of cos 13 pi by 6. So cos inverse of cos of 13 pi by 6 can be written as 2 pi plus pi by 6. So cos inverse of cos 2 pi plus theta is cos theta. So cos inverse of cos pi by 6. So cos inverse of cos pi by 6 is pi by 6. Pi by 6 belongs to cos inverse x range, that is close to 0 to pi. Okay dear students, I will go to question number 2. Tan inverse of tan of 7 pi by 6 equal to tan inverse of 7 pi by 6 can be written as pi plus pi by 6. So tan of pi plus theta is tan theta. So tan inverse of tan theta. So theta. So pi by 6 belongs to open minus pi by 2 to pi by 2. This is the range of tan inverse x. Sine inverse of sine 4 pi by 3. Sine inverse of sine 4 pi by 3 can be written as pi plus pi by 3. So sine inverse of minus sine pi by 3. So sine inverse of minus sine x is minus sine inverse x. So minus sine inverse of sine pi by 3. So sine inverse of sine x is x. So minus pi by 3, which belongs to closed minus pi by 2 to plus pi by 2. Next, we'll move to fourth question. Cos inverse of cos 4 pi by 3, that is equal to cos inverse of cos pi plus pi by 3. Cos inverse of cos of pi plus theta is minus cos theta. Therefore, minus cos pi by 3. Cos pi by 3 is minus 1 by 2. Cos inverse of minus x can be written as pi minus cos inverse x. So, pi minus cos inverse of 1 by 2. Pi minus cos inverse of cos pi by 3. That is equal to pi minus cos inverse of cos pi by 3 is pi by 3. So, we have 2 pi by 3. This belongs to closure 0 comma pi. It is the range of cos inverse x. Okay dear students, we will move to next question. Question number 5, tan inverse of tan of 4 pi by 3. So tan inverse of tan pi plus pi by 3. So tan inverse of tan of pi plus theta is tan theta. So tan inverse of tan pi by 3 is pi by 3. That belongs to open minus pi by 2 to plus pi by 2. Okay dear students. Now we'll move to second bit. That is prove that the following. In second bit, first question, prove that 2 tan inverse of 3 by 5, 2 sin inverse of 3 by 5 equal to tan inverse of 24 by 7. So to prove this result, put sin inverse of 3 by 5 is equal to alpha. So from this sign, bring this side, sin alpha equal to 3 by 5. So wherever sin inverse 3 by 5 is there, replace with alpha. 2 alpha equal to tan inverse of 24 by 7. So tan alpha equal to 24 by 7, we got it now. Equation number 1, you can keep it. Now tan alpha formula you can consider from this. So from sin alpha, calculate tan 2 alpha formula. Tan 2 alpha formula in terms of tan 2 tan alpha by 1 minus tan square alpha, no. So wherever tan alpha is there, replace with 3 by 4. How we will get tan alpha is 3 by 4? From sin alpha, our definition of sin alpha is opposite by hypotenuse, no, 3 by 3 and 3 by 5. So by using Pythagorean triples, you will get here 4. So tan alpha equal to 3 by 4. So wherever tan alpha is there, replace with 3 by 4 and simplify. So 2 into 3 by 4 by 1 minus 9 by 16. So 2 into 3, 6, 6 by 4 by 16 minus 9, 7, 7 by 16. 6 by 4 into 16 by 7. 4 ones, 4 fours, 6 fours are 24 by 7. So equation number 2, tan 2 alpha. So from 1 and 2, 2 sin inverse of 3 by 5 equal to tan inverse of 24 by 7, dear students. I hope you understand. We'll move to question number 2. What is that question number 2? That question number 2 is, prove that sin inverse of 8 by 17 plus sin inverse of 3 by 5 is equal to tan inverse of 77 divided by 36. Okay. See how, in what way we are going to do these type of problems. Okay, dear students. We observe that LHS side in terms of sin inverse, in RHS in terms of tan is there. So what we have to do is, these two also in terms of tan you have to convert. Let alpha equal to sin inverse of 8 by 17. So that implies that sin alpha is equal to 8 by 17. Okay, dear students. Next, this is alpha 8, 17. Here x we are writing by using right angle triangle. X square plus 64 is equal to 17 square, 289, no. So x square is equal to 289 minus 64 is 225. So x is equal to 15 itself now. So from this, tan alpha is equal to 8 by 15. Okay, dear students, I hope you understand. Similarly, beta is equal to sin inverse of, here I forgot to write, 3 by 5. So that implies that sin beta is equal to 3 by 5. Even here also you have to draw the rough figure of right angle triangle. 3, 5 and 4 here. So from this, tan beta is equal to 3 by 4. So therefore this equation will becomes alpha plus beta is equal to tan inverse of 77 divided by 36. So tan will bring this side. You can apply the formula of tan of alpha plus beta. I will turn the page, dear students. So tan of now tan of alpha plus beta is equal to, what is the formula for tan of alpha plus beta? Tan alpha plus tan beta divided by 1 minus tan alpha tan beta. So which is equal to tan alpha and tan beta values. So we got it, no? Tan alpha value 8 by 15. Tan alpha value 8 by 15 plus tan beta value 3 by 4. 3 by 4 by 1 minus 8 by 15 into 3 by 4. Okay, dear students, I hope you understand. So now simplification. 32 plus 45 divided by 60 whole divided by 60 minus 24 divided by 60. So 60 get cancelled. 32 plus 45 is 77. 60 minus 24 is 36. Therefore, tan of alpha plus beta is equal to 77 by 36. From this data, alpha plus beta is equal to tan inverse of 77 divided by 36. But what is alpha we are assuming? That is sine inverse of 8 by 17 plus beta we already assume that sine inverse of 3 by 5 is equal to tan inverse of 77 divided by 36, dear students. Okay, I hope you understand. Hence proved. They are asking to prove this result. Let us discuss the other question. Question number 3. Prove that cos inverse of 4 by 5 plus cos inverse of 12 by 13 is equal to cos inverse of 33 by 65. To solve this type of problems, like previous problem, whatever the procedure we followed, that we can do it. Let alpha is equal to cos inverse of 4 by 5. That implies that cos alpha is equal to 4 by 5. From this sin alpha also you can calculate. Sir, what is the use of calculating sin alpha? I will explain. So cos alpha definition is adjacent side by hypotenuse. By using Pythagorean triples it will become 3. So that implies that sin alpha will become 3 by 5. Okay, dear students. Next, beta is equal to second term cos inverse of 12 by 13. That implies that cos beta equal to 12 by 13. Again, we have to draw the rough figure of right angled triangle and 12 and 13 here. Here obviously 5 Pythagorean triples. So from this sin beta is equal to 5 by 13. After getting these four values, dear students, this value is alpha, this value is beta. Alpha plus beta equal to cos inverse of this one. Cos inverse bring this side, it will become cos, no? So consider cos of alpha plus beta. What is the formula for cos of alpha plus beta? Cos alpha cos beta minus sin alpha sin beta. So therefore cos of alpha plus beta is equal to, now the respective values of cos alpha cos beta sin alpha sin beta here substitute. So cos alpha value 4 by 5 into cos beta value 12 by 13 minus sin alpha value 3 by 5 into sin beta value 5 by 13. So which is equal to 48 divided by 65 minus 15 divided by 65. So which is equal to, denominators are same, we can subtract the numerators. 48 minus 15, that is equal to 33. Okay, divided by 65. So cos of alpha plus beta is equal to 33 by 65. So cos, bring this side, alpha plus beta is equal to cos inverse of 33 by 65. Therefore, alpha value is cos inverse of 4 by 5 plus cos inverse of 12 by 13 is equal to cos inverse of 33 by 65. Hence, proved the result. Okay, dear students, we proved, no? This is the result. This is the way you can do these type of problems. We have the formulas like standard is cos inverse x plus cos inverse y is equal to, yeah, thank you joining for this session, dear students. Yeah, 5 students and 6 students were also joined. Yes, let us discuss other questions. Question number till 3 completed now. We move to question number 4. So question number 4, cos inverse of 12 by 13 plus sin inverse of 3 by 5 is equal to sin inverse of 56 by 65. So here one is cos, another one is sin. Ultimately sin inverse it is there in the RHS. So this is alpha, this is beta, sin, bring this side, sin will come, sin of alpha plus beta. Let alpha equal to cos inverse of 12 by 13. That implies cos alpha is equal to 12 by 13. That implies sin alpha equal to, see, sin alpha, in what way we can calculate it? Right angle to triangle, alpha here. Cos definition is adjacent side by hypotenuse. Here 12, 13 means here obviously 5 will come. So sin definition opposite by hypotenuse, 5 by 13. Cos alpha, sin alpha. This is over. Next, beta is equal to sin inverse of 3 by 5. That implies sin beta is equal to cos beta equal to, even here also you have to do the same procedure, right angle triangle, beta angle here. Sin definition is 3 by 5 opposite by hypotenuse. So obviously here 4. So cos definition is adjacent side by hypotenuse, 4 by 5. So now what we have to do is alpha plus beta is equal to sin inverse of something is there. So sin will bring this side. Now consideration is based on the question, that is the dear students. Consider sin of alpha plus beta. So sin of alpha plus beta formula, sin alpha cos beta plus cos alpha sin beta. So which is equal to sin alpha value 5 by 13 to cos beta value 4 by 5 plus cos alpha value 12 by 13 into sin beta value 3 by 5. So 20 by 65 plus 36 by 65. So which is equal to 56 by 65. So sum of alpha plus beta is equal to 56 by 65. Now sin bring this side. Alpha plus beta is equal to sin inverse of 56 by 65. Therefore, alpha is equal to cos inverse of 12 by 13 plus sin inverse of 3 by 5 is equal to sin inverse of 56 by 65. Hence, proved the result. Okay, dear students, we'll move to question number 5. In question number 5, what they are asking is, prove that tan inverse of 63 by 16 is equal to sin inverse of 5 by 13 plus cos inverse of 3 by 5. So even here also, in these values we are assuming that alpha beta. Every time we cannot say that alpha, A, B also we can take. Now we'll take differently. Let A is equal to sin inverse of 5 by 13. That implies that sin A is equal to 5 by 13. See, from this tan we will, why? Because in LHS, tan terms are there. So, right angle triangle diagram you have to draw with angle A. So, sine definition opposite by hypotenuse. So, adjacent side will become 12 by using Pythagorean triples. So, from this tan A value equal to opposite by adjacent side. So, 5 by 12. Okay, dear students. Next, B is equal to cos inverse of 3 by 5. That implies cos B equal to 3 by 5. That implies tan B we can find. See how we are going to calculate. This is B angle, right angle with that. So cos definition is adjacent side by hypotenuse. So obviously here 4. So tan B is 4 by 3 now. So this is A, this is B, A plus B. Tan bring this side, tan inverse bring this side means tan of A plus B will come now. So now consider tan of A plus B. So for what reason we are considering tan of A plus B? I hope you understand. Tan A plus tan B divided by 1 minus tan A tan B. That is equal to 5 by 12 plus 4 by 3 by 1 minus 5 by 12 into 4 by 3. So, which is equal to 15 plus 48 divided by 36 whole divided by 36 minus 20 divided by 36. So, which is equal to 48 plus 15, 63 divided by 16. So, which is equal to 63 by 16. So, tan of A plus B. So, tan bring this side, A plus B is equal to tan inverse of 63 by 16. So, what is A, what is B? Therefore, A equal to sin inverse of 5 by 13 plus B means what? Cos inverse of 3 by 5 is equal to tan inverse of 63 by 16. Hence, proved, dear students. I hope everyone understand. This is the way we can do the questions. Question number 6. We'll move to question number 6. Yes, students. In question number 6, prove that sine inverse of 4 by 5 plus sine inverse of 7 by 25 is equal to sine inverse of 117 divided by 125. So whenever all in terms of sine inverse is there, means better to take LHS values alpha, beta or a comma b and convert into sine of a plus b formula. Okay. Let a is equal to sine inverse of 4 by 5. That implies sine a is equal to 4 by 5. So right angled triangle, here a angle, sine definition, opposite by hypotenuse, adjacent is 3. So from this cos a is equal to how much, dear students? 3 by 5. Okay. Next, b is equal to sine inverse of 7 by 25. That implies sine b is equal to 7 by 25. From that, cos b is equal to b value 7 and 25. Here obviously 24. $576 plus 49 is 525, 625. So Pythagorean and triples we applied, dear students. So cos b is 24 by 5. Okay. This is a, this is b, a plus b equal to sine inverse is there. Sine inverse bring this side sine, it becomes sine of. Now consider sine of a plus b. You know the formula for sine of a plus b. Sine a cos b plus cos a sine b. So sine a equal to 4 by 5 into cos b 24 divided by 25 plus cos a 3 by 5 into sine b 7 by 25, which is equal to 24 into 4 96 divided by 125 plus 21 divided by 125. So if you add these, you will get 117 divided by 125. So sine of a plus b is equal to 117. That implies that a plus b is equal to sine inverse of 117 divided by 125. What is a, what is b? We assumed here these two. Therefore, in place of that is sine inverse of 4 by 5 plus sine inverse of 7 by 25 is equal to sine inverse of 117 by 125. Hence, proved. This is the way we can get the answers, dear students. Next question number 7. Prove that cot inverse of 9 plus cosecant inverse of root 41 divided by 9, root 41 by 4 is equal to pi by 4. So, such a beautiful question. Here we will go with different trigonometry. Here cot inverse is there. We have formula cot inverse x is equal to tan inverse of 1 by x. Okay. By using this, cot inverse of 9 is equal to tan inverse of 1 by 9. Okay. This is over. Next, here cosecant inverse is there, no? Cosecant inverse of root 41 divided by 4. So cosecant inverse of root 41 by 4 is equal to some a. So root 41 by 4 is equal to cosecant a. So in right angled triangle, here the angle is a. Cosecant definition is what? Hypotenuse by opposite. So root 41 divided by 4. So if you take this one is x square plus 16 is equal to root 41 square. So x square is equal to 41 minus 16. So x square equal to 25 means x is equal to 5 only. No? So from this I am writing tan value. So tan A is equal to, what is tan A? Tan A is equal to opposite by hypotenuse. Opposite by adjacent side. 4 by 5. So this is equal to A, we are assuming that here. So A can be written as tan inverse of 4 by 5 itself now. So tan inverse of 4 by 5. So A, that is equal to tan inverse of 4 by 5. It is looking like tan inverse x. This is tan inverse of y. We have formula tan inverse x plus tan inverse y equal to tan inverse of x plus y by 1 minus xy. So formula. So in place of cot inverse 9, this value. Therefore, tan inverse of 1 by 9 plus this value is equal to this one, no? Inverse of 4 by 5. Is it in the form of tan inverse x plus tan inverse y or not? So tan inverse of x plus y, that means 1 9 by 5 divided by 1 minus 1 by 9 into 4 by 5 is equal. So here 45, 9 5s are. Otherwise 45 we don't know, 5 plus 36. 5 plus 36 divided by 45 minus 4 divided by 45. So 45 cancel. Tan inverse of 41 by 41. Tan inverse of 1. So tan inverse of 1 can be written as tan inverse of tan 1, tan pi by 4. Are able to catch? Tan inverse of tan x is equal to x. Tan inverse of tan x is equal to x. So that is equal to pi by 4. Hence proved. Okay, dear students, I hope you understand. We move to next question, dear students. Question number 8 and 9. We'll finish up these questions in this session. Question number 8. So prove that sine inverse of 3 by 5 plus sine inverse of 8 by 17 is equal to cos inverse of 36 by 85. Okay. So like the previous problems, let alpha equal to sine inverse of 3 by 5. That implies sine alpha equal to 3 by 5. That implies cos alpha equal to 4 by 5. See how can we write directly? See, we already number of times sine definition is opposite by hypotenuse, no? So by using Pythagorean triples, you will get it as 3, 4, 5, the sides. Next, beta equal to sine inverse of 8 by 17. That implies sine beta is equal to 8 by 17. That implies beta opposite hypotenuse. Here 289. Here 15 will be there. 225 plus 64, 289 will come. So from this cos beta equal to adjacent side by hypotenuse. 15 divided by 17. This is alpha plus beta equal to cos inverse. Cos inverse, bring this side, cos will come now. So cos of, now consider cos of alpha plus beta is equal to, so cos alpha cos beta minus sin alpha sin beta. So cos of alpha plus beta is equal to, cos alpha cos beta means 4 by 5 into 15 divided by 17 minus sin alpha sin beta. So 3 by 5 into 8 by 17. So which is equal to 60 divided by 85 minus 24 divided by 85, which is equal to 36 divided by 85. So cos of alpha plus beta is equal to 36 by 85. That implies alpha plus beta is equal to cos inverse of 36 by 85. Later, what is alpha, what is beta, we assume here. Therefore, sin inverse of 3 by 5 plus sin inverse of 8 by 17 is equal to cos inverse of 36 by 85. Hence, proved. Okay, dear students, this is the way we can do it. So we'll move to question number 9 in this session. After 9, we have more 6 questions that we will finish in the next session. Question number 9 is, prove that sin inverse of 3 by 5 plus cos inverse of 12 by 13 is equal to cos inverse of 33 by 65. Let alpha is equal to sin inverse of 3 by 5. That implies, so same thing only it comes now. So sin alpha is equal to 3 by 5. That implies cos alpha is equal to 4 by 5. Okay. Next, beta is equal to cos inverse of 12 by 13. That implies cos beta equal to 12 by 13. So that implies sin beta equal to, so beta is here, sin beta. Cos beta definition is adjacent side by a hypotenuse, therefore it will become 5 surely. So sin means 5 by 12. Okay. Later, now consider cos of alpha plus beta. What is the formula for cos of alpha plus beta? Cos alpha cos beta minus sin alpha sin beta. So cos of alpha plus beta is equal to cos alpha cos beta, cos alpha cos beta. So cos alpha means 4 by 5, cos beta means 12 by 13 minus sin alpha sin beta. 3 by 5 into 5 by 12. So 48 by 65. So sin means 5 by 12. cos beta means the term is correct. 5/13, sorry. So 48/65 minus 15/65. So denominators are same now. 48 minus 15, 33 divided by 65. So cos of alpha plus beta. So alpha plus beta is equal to cos inverse of 33/65. So alpha and beta values we have, that is sin inverse of 3/5 plus cos inverse of 12/13 is equal to cos inverse of 33/65. Hence proved, dear students. Okay, dear students, I hope you understand. Thank you for joining this session. The rest of the questions from question number 10 to 15 we will discuss in the other session. Okay. Thank you, all of you. I'm going to end the session. Thank you for your support.